Problem number 5. Suppose you wanted to conduct a survey of to find the percentage or proportion of Kenyatta College students who take the bus. So there are two formulas that we could possibly use here. These are two formulas that have something to do with proportion. It says percentage there, but essentially the same thing. Proportion. Now let's look at part A. If you want to be 90% certain that you would obtain the proportion with no error, with an error of no more than 5%, what's the minimum sample size? So this is finding the sample size using a proportion. Now in part A, it gives no mention about a p hat or a q hat, an estimated p hat or q hat. And so in that case, we'll have to use this formula. And this formula needs a few values. It needs a value for z sub alpha over 2, your critical value, and it needs a value for the margin of error. And here they say the margin of error is no more than 5%, so we can easily put that there. And that's 0.05 for E. Now for the Z value, you can look at the table or you can use your calculator. Let's do it both ways. At 90%, and this is a proportion, or this is a problem on finding the sample size. So what we want to do is we want to look at it with the z sub alpha over 2 business, and that means we have to cut this in half. And so there's two ways of doing this. One way is to use a table, and you can use table A2, but I'd like to show you using table A3. Now I know A3 says it's a t distribution, critical value, but the values all the way in the bottom of this t where it says large gives exact values for the z distribution, and so that's what we're going to use. So first we note that we're looking at alpha is 0.10, so that's the degree of confidence is 90%, so what's left over there is 0.10, 10%. And the area is in 2 tails because it's a z sub alpha over 2. You can think about it that way, or you can think about confidence intervals. So we're looking at the area in 2 tails as being 0.10. And so if you look at the second from the right column all the way in the bottom, your critical value is 1.645. So we'll make note of that. Critical value is 1.645. Just to show you another way of doing this using the calculator, we can pull out our distributions, our inverse normal distribution, and remember you got the 0.10, but you have to cut that in half, so divided by 2. Now this is going to give you a negative value, but our critical values are going to be positive, so we're just going to want to take the positive value of this. So this is just another way, another quick way of finding your critical value. Let's take a screenshot and save this in our notes. Oops. Let's try that again. Screenshot. And paste it into our notes. So I know I always refer to using the calculators, but this one, I think table A3, not only for your t distribution, but for your finding critical values in your z distribution as well. is really helpful. And just remember to look all the way in the bottom. So these are our values, and all we really have to do now is put all this stuff into our formula. The n is equal to 1.645 squared times 0.25 divided by 0.05 squared. Now in the calculator you can actually do this all in one step. So our critical value is 1.645, and then we want to square that, and we want to multiply by 0.25 and then divide by 0.05 quantity squared. Now if you want to be really careful, you can do this in pieces and use parentheses and things like that, but the order of operations in math allows us to get these values. So let's take the screenshot again. Actually, it's better if we just keep this screenshot and take the other one out. So this is our answer. Now our n is given as 270.6, but this is a sample size, so this has to be a whole number, and for whole numbers in this particular scenario we always want to round up. Now this we round up anyways because your 6 here is bigger than 5, bigger than or equal to 5, but in general if there's a decimal residue like that you always want to round up. So that's part A. Part B, assume that your previous study gives us a p hat, and you want to be 90% certain, so that 90% again is going to give us our critical value, and then an error of 0.05. This time it's not in decimal, but it's the same 0.05 that we've had. So because of the setup, we have the same z sub alpha over 2 is 1.645, and our error no greater than 0.05. And now we have two other things that we need to include. We have our p, which is in percentage, so we just want to make sure that we write that as a decimal. And then that's a 4488444. We better check that. It's basically 1 minus, oops, that's this minus 0.1556. Yep, that was right. Okay, so that's the same setup that we have as before, and so we can just easily put this in our calculator. We got 1.645 squared times 0.1556 times q 0.8444, and then divide by 0.05 squared. Now in our calculator I actually included I squeezed in another command. If I press second and enter, it'll give me the last entry. Let me clear that and press second and enter again, and it gives me my second to the last entry. Now I'm just doing some extra calculator work that might be useful for some people if you get good at it, but it takes practice. So this allows me to get my second to the last entry, and then I'm going to delete the 0.25, and I'm going to insert my my p hat 0.1556, and then times 0.8444. And then I want to divide. I lost my divide sign there, so divide. So you just got to be careful and be meticulous about your calculator work. So here's our value. So if we look, it looks like comparing these two problems, which is a good thing to think about. By knowing a little bit more information about what you're studying, and by having some background or something like that, your n in this case is 143. Remember, you round up. So back to my comment, by knowing a little bit more information about a previous study, this will allow you to be able to get the same sort of results statistically with a fewer sample. So the comparison, 143 samples versus 271, and so this allows us to get a smaller sample if we know a little bit more about what we're studying. Okay, so that's problem number 5.